Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn the structure of crystal lattice. So let us start with crystal structure and crystal lattice. You know friend, crystal structure is one of the most important aspects of material science. And many properties of materials depends on the crystal structure. The basic principle of many materials characterization techniques such as X-ray diffractions, transmission electron microscope are based on crystallography. Therefore, understanding the basic of crystal structure is our paramount importance. So what is crystal? A crystal or crystalline solid is solid material whose constituents such as atoms, molecules or ions are arranged in a highly ordered microscopic structure, forming a crystal lattice and that extend in all directions. My friend, in addition, macroscopic single crystals are usually identifiable by their geometrical shape consisting of flat faces with a specific characteristic orientations. My friend, scientific study of crystal and crystal formation is known as crystallography. Scientific study of crystal and crystalline formation is known as crystallography. The process of crystal formation via mechanism of crystal growth is called crystallization. For example, diamond, table salt, etc. Look at here. Crystal structure. What you are looking here. Three-dimensional growth. A perfect regular arrangement. You can see one small sphere attached with the big, purple attached with the green, purple attached with the green, and this is the three-dimensional structure. So, symmetry in crystal lattice. The most important property of crystal is their symmetry. All the crystal of substance have the same element of symmetry. There are three important types of symmetries in a crystal. They are plane of symmetry, axis of symmetry, and center of symmetry. So let us discuss about plane of symmetry. When an imaginary plane passing through the center can divide a crystal into two parts, such that one is the exact mirror image of the other, the crystal is said to have a plane of symmetry. You can see in this picture. 1. Two portions obtained by imaginary a plane passing rectangularly through the center, then it is called rectangular plane of symmetry. You can see rectangular plane of symmetry. A. Two portions obtained by imagining a plane passing diagonally through the center, then it is diagonal plane of symmetry. So rectangular plane of symmetry, diagonal plane of symmetry, you can see in this picture. Now friend, axis of symmetry. It is an imaginary axis about which the crystal may be rotated such that it presents the same appearance more than one during complete rotation. If the appearance is the same only twice in a rotation, the axis of rotation is said to have twofold symmetry. If the repetitions 3 times, the axis has threefold symmetry. If the repetition is 4 times, the axis has fourfold symmetry. Center of symmetry. Center of symmetry of a crystal is such a point that any line drawn through it intersects the surface of crystal at equal distance in both the directions. Below figure represents the center of symmetry for a cube. A crystal may have only one center of symmetry. Center of symmetry of a cubic crystal. Now friend, lattice points and crystal lattice. Important. The constituent particles, atom, ion or molecules of a crystalline solid are arranged in a regular order. The position of these particles in the crystalline solid relative to one another is usually represented by points, which are called lattice point or lattice sites. The orderly or regular arrangement of infinite set of these lattice points, which show how the constituent particles present in the crystal lattice are arranged in three-dimensional space, is called crystal lattice or a space lattice. You can see unit cell and lattice point. Now friend, unit cell. In the figure, it is found that crystal lattice is composed of an infinite number of small units which are adjacent to one another in three dimensions. Each of these small units is called a unit as shown in the figure. Thus, a unit cell can be defined as the smallest unit of the crystal lattice, which when repeated again and again gives the entire crystal of the given substance. My friend, a unit cell is characterized by its dimensions along three edges A, B, C. These edges may or may not be mutually perpendicular. Angles between the edges alpha between B and C, beta between A and C, and gamma between A and B. So, thus a unit cell is characterized by 6 parameters A, B, C, alpha, beta and gamma. My friends, 7 crystal systems. It can be shown geometrically that theoretically there can be 32 different combinations of elements of symmetry of a crystal. These are called 32 points groups or 32 systems. Some of these systems have been grouped into 7 different categories, which are known as 7 basic crystal systems. So these 7 crystal systems are cubic, orthorhombic, tetragonal, monoclinic, triclinic, hexagonal, rhombohedral. The figures of these crystals is here. You can see cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral and hexagonal. Now classification of a unit cell. Unit cell can be divided into 2 categories. They are primitive unit cell and centered unit cell. Primitive unit cell means when constituent particles are present only on the corner positions of a unit cell, it is called a primitive unit cell. When a unit cell contains one or more constituent particles present at position other than a corner, in addition to those at corner, it is called a centered unit cell. So, the importance point, Brevis Lattice. The French crystallographer Auguste Brevis in 1848 showed from geometrical consideration that there can be 14 different ways in which similar points can be arranged in a 3-dimensional space. Thus, the total number of space lattice belonging to all the 7 basic crystal systems put together is only 14, and these lattices are called Brevis lattice. Cubic unit cell has three different types of arrangement of lattice point which give rise to three different Brevis lattice. They are body-centered cubic lattice, face-centered cubic lattice, end-centered cubic lattice. So body-centered cubic lattice means in this structure there are 8 spheres at 8 corners of a cube, and one sphere is in the center or body of the cube. In this structure, each sphere is in contact with the 8 other spheres, and hence the coordination number of each sphere is 8 in this structure. The total number of atoms present at the one body centered cubic unit cell is 1 by 8 number of atoms placed at the 8 corner of the cube plus number of atoms situated at the center of the cube. So 1 by 8 into 8 plus 1. So 1 plus 1 is equal to 2. Body centered lattice is labeled as 1 is represented only in cube, orthorhombic and tetragonal crystal lattice. Face-centered cubic lattice. In this structure, the atoms are present at all the 8 corners of the cube and at the center of each cube. In this structure, each atom is in contact with the 12 other atoms, and hence the coordination number of atoms is 12. The face-centered atom in the front face in contact with the 4 corner atoms and 4 other face-centered atoms behind it, and it also to touching 4 face-centered atom of unit cell in front of it. So total number of atoms present in one face-centered cubic unit cell is 1 by 8. Number of atoms placed in 8 corners of the cube plus half number of atoms placed at the 6 center of the 6 faces of the cube. So 1 by 8 into 8 plus 2 half into 6 is equal to 4. So this type of lattice is labeled as F and is present only in cubic and orthorhombic crystal system. End-center cubic lattice. In this structure, the atoms are present at all the 8 corners of the cube and at the center of the 2 end faces of the unit cell. There are total 10 atoms, 8 atoms each at the corner of the cube and 2 atoms at the center of the 2 end faces of the cube. In this structure, each atom is surrounded by 12 other atoms, and hence the coordination number of the atom is 12. This type of lattice is labeled as C and is present only in orthorhombic and monoclinic crystal system. Total number of atoms present in one end-center cubic unit cell is 1 by 8 number of atoms placed at the 8 corner of the cube, half number of atoms placed at the center of the 2 faces of the cube. So is equal to 2. Now friends, you can see the Brevis lattice crystals. The Brevis space lattice associated with the various crystal systems are given here. The parameters of unit cell, that is the cell dimension ABC, and the interfacial angles alpha, beta, gamma are also shown in each case. So you can see simple cubic, body-centered cubic and face-centered cubic, simple tetragonal, body-centered tetragonal, simple orthorhombic, body-centered orthorhombic, base-centered orthorhombic, face-centered orthorhombic, rhombohedral hexagonal, simple monoclinic, base-centered monoclinic and triclinic. So this is the table, its importance. Cubic A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree, number of Brevis lattice is 3, 4 3-fold, and example sodium chloride, zinc sulfide, and so on. You can see. So I will discuss this point in our next video. So if you like this video, then subscribe my channel, and thanks for watching.